to choose the experiment. So if you receive the mail, it means that you will do the 5 experiments next week, and you have a pool of 9 to choose. So just to gain time, please go to the form until today, at the end of the day, at the end of the school, that is 6 p.m., and complete with your preferences. If you don't complete it, we will assume that you have no preferences, and we will assign wherever we want or where we have room. Okay? So I don't know where is my presentation. The idea is to present a little, I don't know where they put it. Could you ask the, okay, so I will continue with our presentation for the moment. So then there are few students that will not, cannot do all the experiments. I think it's very few, it's 4 or 5 or something like that. So for those, we will see where we have room. We have room for some of the experiments, and we will do a schedule, and we will propose something. We will try to give you as much of things we can, but for sure will not be all the days, because there are some experiments that they are available for a small number of people, so each day. So I forgot that. Thank you.
No problem.
The idea now is we will present a little what we are going to do in each experiment, so this will help you to decide or to make your preferences. So since more of the professors that will do the experiment will arrive during the weekend, I will try to do my best on trying to let you know what they will do, and they prepare one slide. Yes, exactly, one slide, and we will go through that. Also in the web page, you have the experiment, and you have an abstract, and also in the title of the experiment now you have a link where you have the guide. This is the practice guide that we will use during the hands-on, so this also can give you a better idea on what is going to happen there, okay? So this guide is something to follow, but it will depend also on how the course will develop. Each day could be a little different, or each group can have different needs, and so on. So they will not follow exactly as when you go to the university lab that is like a receipt. So the idea here is not to do a receipt, is to learn experimental techniques related with dark matter and neutrino detection. So I think I already say all that. So the list of which experiments you will do each day, it will be available on Monday morning before lunch. So we will let you know all the week schedule in advance. So the experiment will happen in 2 places. One place is where the school will happen next week. That is the Principia Institute. So this is nearby for 20 steps from the hotel. I already count on that. So it's very easy to go there. And we have 2 places where we'll be. One is what we call the dome. This is where we will have at the morning lectures, and this is for everybody. And then there's another building here with 4 floors, and in this room we will have these 5 experiments. We will have signalization clear for found that. We will be there to help, and you can see here where they happen. At the end of the day, we will explain you a little more how to reach this place and where you have to go when you arrive very sharp on time on Monday. The other 4 experiments will happen at USP, that is the University of São Paulo. So for going there after the morning lectures, we will organize you in groups by Uber. The school will cover the Uber. Martin will organize this on Monday, and then we will learn from this organization for the rest of the day. And the idea is that the morning lecture finish, you take the Uber, you go to USP, Edivaldo will let you know where you will have lunch. He will receive you there. On Monday, we will have lunch in the same place every day, but it's going to be different people. And then we will split in 4 places. One will be in IPN, that here is an institute that they have experimental nuclear things, where you will do the activity, the lab 9. And then the other 3 will be in this building, that is where Professor Sadeus Piedivaldo is. So he will show you how to reach these places when you arrive there. So let's move a little on the experiments now. So the first experiment will be given by Darío Rodriguez. He's from the Buenos Aires University, and he knows a lot of statistics. And we asked him to prepare a course where we can learn how to analyze data related to dark matter and neutrino experiment to put sensitive and exclusion limits. So you don't need to have a huge, strong background on statistics for that. But in the practical guide, there are some tips or places where you can look Poisson distribution and Gaussian distribution and things like that. And also the idea is that you will have in the first parts of the courses, you will have some discussion with him and learning, and then you will apply all what you learn on setting these limits, because the way to do things or to learn things is by doing. You will have to use some Python notebooks. We can use Colab, and he prepared something already very easy to go through to the process. So the idea is that you will learn how to put the limit of the experiment where you want to work. So this is the first one. The second one is relating with Monte Carlo simulation. Since Laura, that is one of the professors, is here, she will explain, and I will be just near you because of the camera.
Okay, so Monte Carlo simulations are very important nowadays in experiments, both when you are in the design phase and construction, and if you have to reconstruct, let's say, very complicated topologies. So the idea here is to introduce you to one of the main techniques used to simulate in particle physics, which is GEANT4. And in particular, we will be analyzing noble liquid experiments. So we will introduce GEANT4, introduce how it has been able to take optical photon simulation, and then we will do some simulations and then some analysis in particular liquid argon experiments, which are useful both to neutrino and dark matter experiments.
Good. So then the number 3. The number 3 is a very nice special thing for me, because Ana Botti, that now she's a Fermilab, she's an Argentinian, she did the school 6 years ago. She was finishing the PhD, then she came here, she did the CCD lab, she got in contact with the CCD people at Fermilab, now she's working for that, and she will be a professor of the school, so this is a very nice story. And what she prepared is a discussion related to silicon detectors, CCDs, and CMOS for particle detection. You know that you can use for optical things and take pictures, but here we use as particle. So the idea is to make a discussion on that, and then use these CMOS cameras that are very nice, easily to use, cheap, very easy to move around the world, just to do a calibration to understand how it works, and then to use them to detect particles. So here you can see some particles. This is a muon, and you will learn how to identify that. Then this is an electron, and this is some low energy stuff. And then by measure the energy of those events, you can build a spectrum, and this is the idea of the experiment that you will do in one afternoon. Then it's very important also when we run this kind of experiment to control the background, and some detectors have time resolution. You do veto just to reject some kind of background, mostly cosmic rays. And this is the idea, the aim of this laboratory is to use a system based on plastic scintillator, that is another very nice and easy to hand detector, just to create this veto detector and understand how it works, characterize, and you have to detect the light produced in the silicon detector. You have silicon PM, so you will learn also about silicon PM. related also with silicon no, so I forgot. This is another one. So then another silicon detector is this time peaks that is used for LHCb. They have this, also is a pixel detectors, and the idea with a threshold, energy threshold much higher than CCDs, but the idea is to use this just to characterize the interaction of radiation, and also to see some tracking. So the idea is to learn how to use that, to measure different radiation sources, and to recognize the peak, and then to make the full analysis and get some spectrum. Going back to silicon detector now, yes. So we have a lab that is very dedicated to understand much deeper than in the number 4 how a silicon detector works. So the idea is to discuss all about silicon detector here, measure the dark current, make some characterization, and then, as if time allows us, go to more detailed measures in order to understand the silicon PM properties. So maybe we will try to avoid to have 4 and 6 because there's some overlap, but if you are interested in this technique, also you can do both because you will see the silicon detector from a different point of view. And then we have other 2 experiments that will be done by the group of Edivaldo, and since Edivaldo is here, I will ask him to present both, the 7 and the 8.
Right, so the idea of this activity is that to separate photons from neutrons, right? We have this kind of task to do when you try to do low energy measurements in liquid argon. You have to separate neutrons from photons. So this is a general activity to teach you how to do that. We're going to use a scintillator, a plastic scintillator for that. And so this plastic scintillator responds differently to neutrons and photons. So the technique is called a PSD, so you're going to learn how to do that. So we're going to use a gamma ray source, an emission source, a plastic scintillator, and the electronic associated. And so we're going to take some data with this source, and then we're going to handle you some data that was previously taken with neutrons and photons, and you're going to learn how to separate the 2 populations. So basically that. And then the second task is also related to the previous one. You're going to use a very similar setup, and we're going to use the same scintillator, and we're going to measure the energy resolution of this scintillator. So for that, we're going to also use a radioactive source and Compton scattering, so in a specific geometry. So we know exactly the energy of the photon, so you can then see what is the energy resolution of this scintillator. So the whole idea of these 2 activities is to learn something about plastic scintillators, because this is a very common detector being used nowadays for dark matter experiments, something like that.
Okay, good. And then we will move to the last one, that is something that we should also discuss and have, that is gamma radiation. So the idea of this experiment is to use a high purity germanium detector, and it's a detector that is very used a lot for dark matter neutrino searches. And the idea here is to characterize the gamma spectrum, first using some radiation sources, but then also studying the environmental gamma spectrum, and also maybe you will have a non-known sample, and you will try to discover what you have. So for this experiment in particular, that it will be in the IPN, we need to enter with, I need to put the name in a list because they're nuclear stuff and they have more security issues. So that's why in the Google form we are presenting, we are asking you, the ID. You need to go there with an ID with a photo. Otherwise, you will not be able to enter, and you need to have more than 18 years old, but I think this is the case for everybody, so I don't worry about that. So Guilherme is the person that will receive you and will guide you on the whole afternoon. So then I think I have something else that I don't remember what it is. Okay, this is how the Google form looks like. So please fill this. The deadline is today, 6 p.m. If you have any question, we have the afternoon. We can discuss. You can look for us and so on. So there's a question now.
You mentioned that there would be one on Friday that everyone would do. Which one is it?
Sorry, is there one on Friday?
You want experiment on Friday that everyone can participate?
You don't want?
No, I'm asking which one it is.
No, I will allow you. I will let you know the schedule of all the experiment on Monday. So a priori, which person will do anything up to now. So I will look at what you prefer, at the preferences, and I will try to keep the first 5 preferences to everybody. But if all of you have the same, this will not be able to. That's why we want you to rank the 9 experiments. We will try to do our best just to fulfill what you want, but we are not sure if this will happen. Up of the 9, you will be allocated for doing 5, because you will do 1 experiment each afternoon, okay? Any question about that? It's clear? So 1 is the one that you prefer the most, okay? And then you continue up to 9. Martin?
So just before we break for lunch, yes, there's a question.
You guys mentioned that there was going to be a virtual machine that you were...
Yes, the virtual machine is done, and you will have the link on the experiment part of the web page in the school. Also, if you are a person that have Xeon in your laptop, congratulations first, and then second, you can use your Gen 4. So if you don't want to use the virtual machine, then you have a link with extra material that is what you need to run the experiment too. So if you don't want to use the virtual machine because you have already Gen 4, you can only take the other part that are the complementary things that you need. One important thing is that we ask you to bring your laptop because most of the experiments have some data analysis. That it's nice that you take the data you take with you, and also you use your laptop to do the code and so on and so on. But we know that there are some students that have not. So that's why we are asking you again if you bring your laptop, because maybe you forgot or something happened. So please fill that very well, because what we will do is we will assure that each 2 persons we will have 1 laptop, so you can share with the colleague. So you will work mostly in pairs, okay? Because otherwise nobody works. So even if the experiment you will be 4, you can have 2 groups of 2 doing the analysis and discussing, okay? Any other question? Eliana? No, it's the 1 to 9 in this order. So you cannot put 2, 1. If the Google form say no, you cannot do that.
Can you repeat the question?
If, Eliana asks if you can choose more than 1 experiment as the fair option. No, this is not possible. So 1, 2, 3, up to 9. So I understand that if you put 1 and 2 are the most 2, the 2 first that you want. So second and 1. We will try to give you as much as we can what you want, okay? And then once this will be divided, no way to change, okay? No way to change because we are 50. This is a lot, and it's a nightmare just to do the distribution. The only thing that can happen is that, for example, Liana and another one, and Jose say, okay, we will exchange between the 2 of us. But not for the night, because the night I have to give the name, the ID, and the date you will go there. And this should be, it needs to happen on Monday morning. Otherwise, you will not be able to enter there, okay? But for the others, if you arrange with someone and you communicate in advance, okay. But we will not change you I don't want to do that because now I want to do another. I'm so sorry. Oh, I asked for this and you give me the other one. I'm so sorry because it's very difficult. So I hope that you can understand our side.
Okay, just a few further clarifications. As you know, the number of persons per experiment is very limited so that you really can interact with the experiment and so on. And that has obliged us to limit the total number of participants that can do all the experiments to 50. So we are happy that I think we accommodated everyone that register in the school at the regular time. Even if initially they couldn't do the experiment, I think we were able to accommodate everyone that was registered on time. We admitted other people in the school later, you know, but so maybe we could not accommodate them, but at least I think we are happy that I think we accommodate everyone that was registered in the school. That's one thing. And we apologize for those that cannot do the experiments. I mean, sorry about that, it's live, but at least you could attend the rest of the school. The mornings of next school are still classes, so everyone would go to. And those that cannot do all the experiments, but we will arrange to attend at least one of the, or two experiments. So, I mean, there are two, the vast majority will be able to do 5 experiments, 1 per day. And the other ones would be able to do 2 experiments, so don't give up. So that's one thing. The other one is that, well, you know, in life, many processes are random. Sometimes we don't acknowledge that much, right? Not only in physics. So there is a lot of randomness in life. And so there is like, perhaps you are here and some other person is not here. We evaluated people, but there is randomness. So there is a lot of unfairness. So, you know, when assigning the experiments to people, we'll try to accommodate a lot of things, right? Like priority, and we want to have a mix of people that have laptops and not laptops and many other things, but there is some randomness. So, you know, apologize, but as Carla said, there's no way of changing. That's a very complicated algorithm to assign people to the experiments. The good thing is that all experiments are super nice. So even if you didn't choose, I mean, even choosing experiments is hard, right? I mean, what do you know about the experiments besides a short description, right? So it's a random for you to select, maybe hard. For us, it's random and hard to select you. So at the end, you know, you make nice experiments. It's like, okay, I had nine, I only can do 5. Yeah, that's life, don't worry. So that's the second thing. And also, like, requirements for the experiments are different. So, for example, as Carla mentioned, the identity card is something that you need to have with you if you go to one of the experiments, which is in the IPEN, in the Nuclear Institute. So you know ahead of time on Monday, right? We are on the side of the hotel, so no problem. So you know on Monday if and when you need to take a document, right? When you fill the form, you do have to put your document number because at the beginning of the week or over the weekend, the people at the Institute will have the full list of everyone on the 5 days that will participate. So they need that list with documents. So we ask you to fill the documents, even if you don't choose this experiment, even if you don't do this experiment, but we need this information ahead of time. So once we assign 5 groups to the IPEN, they will have the identities. And you will know if you are assigned to that, don't forget to bring your identity because you need this to enter the building, right? So regarding laptops, yes, most of the experiments require laptop. If one doesn't, we will let you know, so you don't need to bring it. I think that's all.
Yes, and double check your identity because we know that time to time you put a bad number and then it could be a mess. So please pay attention that.
And put the number of the identity you can take with you, of course, right? So yes,
with photo.
We will break for lunch. We continue all afternoon with Mateus, and we will organize how it goes. And at the end of the day, we'll give more information for next week, okay? Thanks.